welcome back. So I'm Teacher Jess and welcome to GeoCafé. I know a lot of matrics are busy learning about tropical cyclones and stuff. So I thought we could look at a case study and I found Hurricane Lee. Before we actually jump into Hurricane Lee, I thought we should just recap hurricanes. And hurricanes bearing in mind, I teach a South African. So we don't usually refer to them as hurricanes. So we would refer to them as tropical cyclones. So let's just maybe start by looking at what cyclones are. So cyclones are low pressure systems. Okay. Well, cyclones are a low pressure system. They move in opposite directions in both hemispheres. So in southern hemisphere, they move clockwise, cyclonic. Northern hemisphere, they move anti-clockwise. That's also cyclonic. Sorry, I was about to say No, that's also cyclonic. Anticyclones are the opposite. Anticyclones in the southern hemisphere move anti-clockwise in the northern hemisphere. Okay, but that was just a little side. So, tropical cyclones, what makes them somewhat more unique is that they are tropics. So, this little map over there, just to show what we're talking about. Tropics. There we go. So there's our tropics. There's our Tropic of Cancer, there's our Tropic of Capricorn. And in between, we tend to find a lot of tropical cyclones, aka typhoons or hurricanes or whatever else. There are a few reasons for this. The main one being this is where it's very. So maybe if you're in grade 11 or so, you would have recently looked at the Earth's heating, how there's so much heat around the equator and there's less towards the poles. Well, around the equator, they receive the sunlight, consistent sunlight as well throughout the course of the year. So between the tropics, it is the hottest. Interesting little side note about tropical cyclones is that they don't form. They form just on either side, so like just outside of 5 degrees. So it has to be more than 5 degrees, but less than 20 degrees in those two little things. That's where you'll find hurricanes or tropical cyclones. There's a reason for that. One of the ingredients that a tropical cyclone needs is Coriolis force. Now, this is not meant to be a lesson on Coriolis force, but essentially, it doesn't happen at the equator. Coriolis force is the little thing that makes everything spinning. So it's the force that has all wind movement spinning in some or other direction. And that does not happen at the equator. At Coriolis force, we can't have a tropical cyclone. So that is one of the requirements of a tropical cyclone, Coriolis force. The second is warm water. If I remember correctly, it needs to be at least 28 degrees Celsius. So I found this delightful website. I absolutely love this website. It's called Null School. Okay, now you can see as all the water stuff is moving. And I'm going to switch it to this SST, that's sea surface temperature. So around the equator, we see this like dark maroon, a little bit of purple. There we go. A little bit of purple, dark, deep burgundy, beautiful, rich colors. There you go. Okay, now you can kind of see how the currents are moving. See there on the bottom left where it says it's 30 degrees Celsius. So that is warm enough for a cyclone. Then the next thing, or final thing, that a tropical cyclone is wind shear. Now check that quickly. I'm going to change the animation. There. See that lovely little spiraling in a clockwise direction. Clockwise, telling me cyclonic, also telling me that this is a low system. Okay, that has all of the raw ingredients. So if I check 29.9 Celsius, moving in a clockwise direction, in the right latitudes, that has all the raw ingredients to be a tropical cyclone, or maybe it was a tropical. So let's take a look to Earth. So I'm just going to go straight back to where we found that little twirly-whirly that I said could be a cyclone. Oh yeah, there's a thing. That looks like that's a something. That's a thing. Tropical disturbance. So it looks like, yeah, that's in the same spot. There it is over there. And there it is over there. And it looks like it's very new. Okay. Okay. Maybe we're busy witnessing the formation of tropical cyclones. Cool. Okay, so let's check out hurricane. Now we know how it's formed. We know what tropical cyclones are. We know how they are formed. And I want to see if we can find hurricane on Zoom. Okay, so when was it? September last year. Wow, you could see there were a lot of hurricanes happening at that time. Nigel, and there's Lee. Okay, now what I want you to generally notice is that everything that is happening in the atmosphere. All of the tropical cyclones are around here. There, there. There's not much happening in the southern hemisphere. Nope. Nothing exciting happening in the hemisphere. There. Reasons for this. Remember we said that a tropical cyclone heat to warm oceans and warm ocean currents. And in the middle, or I suppose not, but in the midst of winter, we're going to have the coldest of oceans. Everything around here is still quite cold. In fact, if we go to Zoom Earth, null school, so there we can see the orange where it's quite warm or hot. You can see we're sitting at an average of like 31 degrees over there. Sounds right. Over here, also quite warm, orange, yellow. As you get to the green, it's colder, so the green areas is about 15, and the blue is very cold, nearing sub-zero. So this is supposed to be summer in the southern hemisphere, and then if I switch there, it's summer in the northern hemisphere, and you can see all of the red towards the top sections towards the north, so that's where all the heat is. So this is the one that I wanted to look at, Hurricane Lee. I must say this website is very useful. I can see so much information about this. Lee was started off as a nice little tropical disturbance, so nothing exciting first. It started on the 4th of September with a nice little disturbance, and it only actually turned into something on the 7th. That's actually quite quick now that I think about it. That's not a short time span. And I think it ramped up to impressive category. There we go, category 5. Wow, that is insane. That could do some serious damage. And also because of the sea swells or the storm surges. So because of the storm surges, a lot of damage also caused. I did a case study with my class recently where we actually looked at where they made landfall. It was very destructive. And it was most destructive for, I think it was Jamaica. And it was a very interesting case study to look at how Jamaica was so hard hit by that hurricane to Florida, that was also in the midst of it. And one of the main reason why was just because how prepared each is and the types of technology and warning systems. So let's see if it completely missed all of the countries. I'm gonna kind of move up the animation. Oh no, not by hormone. I'm gonna kind of move up the animations. Okay, there we can actually see the edges. What they're called rain bands. The parts of the hurricane, in this case hurricane, that spirals around towards the eye, that is the I got massive very quickly. Nice thing about this site is that we can actually check how big. So I'm gonna go measure the distance on that. Wow. Okay, that is a kilometer wide. That is massive. I completely understand how its impact just spread out into every direction. And notice how much wider it is since it was at its strongest. That's an interesting comparison. Because we would typically think like a strong, destructive hurricane would be huge. Now let's just go back to when it was at its peak. Ah, get back there? No, not really. Okay, this seems to be the closest that I can get to category 5. Measure. Okay, still quite sizey. Um, but not as big as it was when I was getting close to those countries. And that actually tells us a lot about how we categorize hurricanes. So hurricanes are classified strength by the wind speed. There is our little hurricane. Hurricane. I should be able to see speed. Oh, there it is. 136 kilometers an hour. So that is how we categorize them. So we categorize them according to the wind speed, and as we go through the days, we should days back. So it seems like the highest wind speed was 270 kilometers an hour. That is insane. Yeah, no, no. Let's take a look at the actual stats. Yes, 270 kilometers an hour was considered the highest winds. That is incredible. I do find it really interesting that it started to die down, or it started to lose some of its energy over the ocean, because the warm, moist air is what fuels the tropical cyclone or the hurricane. So it will take up the moisture, and it will take up all of the warmth that's inside that moist air, that and it will force it to condense. So I wonder if I can nice cross section of a cyclone. So this was the diagram that I was looking for. I don't know if I can open it up nicely that we can see it. No. Open image, please. There we go. Yay! So, okay, now the geography teacher in me immediately looks counterclockwise. Counterclockwise or anti-clockwise means that this is in the northern hemisphere. Now, I know that it's in the northern hemisphere. I'm confirming that by seeing it says hurricane. In the southern hemisphere, it will move in a clockwise direction. So the rain bands, they spiral around, in this case in an anti-clockwise direction. They will spiral around and scoop up all of that moisture, and it will lift that moisture up in massive cumulonimbus clouds. And as it rises up, it's a specific type of cooling that as it rises up, it cools very suddenly, and it forces that moisture to condense. And as it's forced to condense, it releases this energy, it releases this latent heat. And that energy is what drives the hurricane. So it's absolutely amazing how these massive storms are fueled by condensation, just condensation. So that's what they do. So they go spiraling around, they gather up all of that moisture, they lift it up very suddenly, it condenses, and releases this heat, this energy that it can use. And then what you see right in the middle over there is when, yes, I am a geography. Secondary school. I'm actually not familiar with that. I teach high school, so I teach grade 8 to 12 across all of the older grades. The idea is for this to be useful for anyone who's wanting to learn about geography. Maybe they're struggling with the subject in the classroom, or maybe they just find it interesting. Yeah, no, it's a big range, but it's actually very nice for me because then I get to see how they grow and how they develop. You know, I might have one student who is struggling with coordinates in grade 8, and then now they're in grade 12, and they are just mastering geography, and they look back to when they were in grade 8 and they think, how on earth did I not get it back then? So it's very heartwarming for me as well. Oh, don't say that. Your teachers work very hard. I'm not meant to be a replacement. I'm meant to be a support. Oh, right. The last little thing that I wanted to point out over here was the air that's sinking back. So you have all of this air rushing up, and some of it has to come back down again. So it comes back down in the middle. And then when it comes down in the middle, it creates this clear patch. So, oh, thank you for following. That's so exciting. Thank you. This is only my second ever stream, so this is a really big threshold for me. Yay. So the air would be sinking back down, and when the air sinks back down, it can't condense. So for condensation to happen, the air has to rise and it has to cool. Then we can get clouds. But if the opposite is happening, if the air is sinking, no rising, no cooling, no clouds. So that's why the eye of the storm is always clear. It's like little leftovers that are coming back down. So looking at the ins and the outs of this hurricane, I'm very curious about why hurricane. Oops, sorry, that was the wrong map. Why Hurricane Lee dropped a few categories, because it's still over the ocean and it's still between the tropics, so it will still be quite warm. I would guess, I haven't actually researched enough about this. I would guess that maybe it was losing the wind shear, because it needs that wind shear to start it. It needs the wind shear and it needs Coriolis force. Maybe it was losing the wind shear, or it could also be moving into a high pressure area. So tropical cyclones need low pressure to start, and they are massive low pressure systems. Maybe moving into a high pressure cell, it was losing some of its energy. And then they typically deflect away from the equator. So here it's deflected north. And I'm glad to see that it deflected north before it hit too many countries. They were still affected. So when I was doing some research over here, we can see, unfortunately, there were still fatalities. So read directly. I would then presume it was, there it is. I don't know if you guys can read that. Brought rain and gale force winds. Oh wow, that's terrible. So I would assume then the damage that was caused by Hurricane Lee was because of storm surges. So your storm surge is actually the waves, the swells that would come in hurricane. So obviously the hurricane, with its massive wind, it would be stirring up the ocean a little bit and blowing in all of its waves. So even though the hurricane didn't reach the land, it still would have had an impact on them. Maybe heavy rainfall. Map again. There we go. Maybe heavy rainfall or just storm surges, but it absolutely would have had an impact. Hurricane gone. Oh, there you are. Back. There we go. So then we can just see how massive the storm actually was. And you can see that the rain bands, they do reach out quite far. So that would have brought some miserable weather for anyone living in these areas. So there you can see overlap. So that's what we call a rain band. That's a band of clouds that kind of looks like it's being sucked into the tropical, the hurricane. That would have definitely brought some awful. Can you see real time? Yes, I do think we can. So let's go take a look. Oh wait, sorry, that's an animation. I don't like that. But this is today's the 11th. Yeah, so this is present. So it's very quiet at the moment. Not much happening down here. We have what might be a little low pressure. I don't know. Um. Oh wait, here's the thing. What's that? There's another little low tropical disturbance. This. Oh, that became a tropical cyclone very briefly, but that counts. So it started in January, the end of January. Just turned into a little something in February, very briefly. There it was a tropical depression, and then was an actual tropical cyclone for one day, just category 1. It definitely does not know where it's going. You notice it just kind of like zigzags all over the place. Oh, this is an interesting thing that I explained to my students. The cone of uncertainty. So when we model these simulations, we don't always know where it's going to go next. So we try to estimate where the tropical cyclone is going to hit. So here, let's just bring it there. So that's where it is now. See some of the clouds, and they estimate that it will probably go there next, but it could be anywhere in this cone of uncertainty. And that is one of the reasons why hurricane tracking and tropical cyclone tracking is so important, because we need to know, are these people over here in Fiji about to have a miserable time, or is it maybe going to deflect south and just miss them? They would need to know this. So they would need to know what is the forecast saying? What kind of warning should we be giving them? Are they just, bunkering down for a rough storm, or could there be intense flooding happening? There's a lot. Yes, the uncertainty. That is the worst. I think it was, I was doing research on this for my one lesson. I think it's the Florida Keys, where they estimate that it takes about 31 hours to evacuate everyone from the Florida Keys. And you can only really project a hurricane where it's going to go within 4 hours. So there's this uncertainty for the people that are living there. You need to know before 31 hours if the hurricane is going to hit them. But they can only say with certainty like 24 hours in advance. So there's this, we might have to evacuate you, you might all have to leave, but then there's a chance that it's going to miss us altogether. But there's a lot of personal and financial cost to that. I mean, imagine these people are going to be leaving their homes, they're going to be leaving their businesses, they're going to be leaving everything that they have and thinking there's a possibility that I won't be able to come back to this. I'm going to gather up what I can fit into my car, and this might be all that I have. Or I'm going to turn on the news tomorrow morning and say, no, the hurricane went in a completely different direction, I'm fine. So that must be utterly traumatic in its own respect. I know that we have very much, I would not want to. One of the things that we look at is what we can do to reduce the impact of these tropical cyclones. And one of the things is changing the land use of the areas that are most likely to be hit. So instead of building skyscrapers and big city centers at the middle of the hot zone, you try to designate it to maybe open fields or recreational areas or something that wouldn't have such a big financial cost if it was hit. But that's not a solution for everyone every way, because in many places it's estimated that something like 51% of our global population or our cities is on coastal lines. And for many places, there's nowhere else for them to go. There's nowhere else for them to live or to farm or exist. We need to remember that human beings can exist where we can make food. And if the coastline is maybe the only place where we can farm, then that's the only place that will be settled, even if it's vulnerable to these massive storms. So we can look at the little islands here. These ones, all of these are in the trampling path of typhoons. This would be typhoons, yes. So this is all in the path of typhoons. They would come, sweep in, and destroy anything that's set up over. So they can't necessarily leave. They can't use their countries for something else. The best they can do is just try to prepare, try to anticipate, and then repair what's left behind. So I think it was, yeah, this area is also very vulnerable. In South Africa, we're quite fortunate to have Madagascar. Yeah. This is where all of our tropical cyclones come. Okay. And then they will deflect south, away from the equator. And we have Madagascar that acts as a bit of a barrier. So we need to be very grateful to the people there. They are the reasons why we aren't really hit cyclones. But the unfortunate thing is that Madagascar is not a very developed country. So they don't always have means, the technology, and the finances to pay for and put together the pieces of their broken lives after the tropical cyclone hit. Well, I hope that you guys have had a nice time. Maybe you learned something new about hurricanes. Yay, drank your coffee. Yes, that's GeoCafé. So I tried to come up with different themed mugs. So today was But First Coffee. That's the kind of teacher I am. Coffee. So please bring your coffee cups next time and we can chat all things geography. I hope you guys have a great day further. Bye. I will see you next week. Have a good day.